Hello, ladies and gentlemen. Today we're going to be talking about dilations. So if you missed this because you missed class, or you're just looking for a little bit of extra work to do before a test or a quiz, this would be a great place to start for non-isometric transformations. That means transformations that change the size of your shape or object that you're looking at. So let's get into it. If we're changing the size of a shape that we're looking at, that I kind of gave away, I should have said spoiler alert before, then there has to be a reason that the size is changing. The size of a shape doesn't change if you don't change anything about the shape. Well, the aspect of dilations that change the size of a shape is called the scale factor. Now, the scale factor here is 2. And if we look at the coordinates of our vertices, which is the plural for vertex, A went from 1, 1 to A prime at 2, 2. B went from 1, 4 to B prime at 2, 8. And C went from 4, 1 to C prime at 8, 2. Now, hopefully you do see the relationship there between the number 2 and the change in the coordinate values. If we take each x and each y separately and multiply them by 2, we get the new coordinate value. 1 times 2 is 2. That's why 1, 1 went to 2, 2. 1 times 2 is 2, like we said, and 4 times 2 is 8, which is why b went from 1, 4 to 2, 8. So, the coordinates of the vertices were multiplied by 2. Okay, so I wouldn't expect you to get this next part off the top of your head, but it is as if we took x, y, and brought it to, that's what the right arrow means, 2 times x, 2 times y for our new coordinate point. And then if you were doing this with the class, you would share it to class and see everybody else's responses. However, we are doing this together, so there's nobody's responses to show up here. All right. Slide 2. Once again, we're finding the scale factor from triangle ABC to A prime, B prime, C prime. And it's very important that you go in that direction. From ABC, the pre-image, to A prime, B prime, C prime, the image. Now, we've talked about those two words a lot when we looked at transformations. We should know that pre-image is the shape before it's been modified, and image is the shape after it has been modified. So when we start with ABC, that's the pre-image. A prime, B prime, C prime in this case will be the image. So you'll notice that the shape seems to have shrunk. It is not as large as the original from ABC to A prime, B prime, C prime. A started at 4, 4, but became 2, 2 with A prime. C from 4, 0 to 2, 0, and B at 4, -4 to 2, -2. So you can pause the video and just take a second to think about how would I get from 4, 4 to 2, 2 and apply the same operation to get from -4, 0 to -2, 0. If you said divide by 2, you're really, really, really close. Another way of saying divide by 2 in the spirit of multiplying would be to multiply by 1/2. So the scale factor was 1/2. And you can see this enters as a fraction, so that way you don't have to worry about the different keyboards in Desmos that we've used this year. It'll just enter as a fraction right away. I'm giving this little bit of commentary to you guys because I do think while it's valuable to watch this video, it would be even more valuable if after watching this video, you went back and tried this lesson yourself. It's only 4 slides. It's not that long, but just to reinforce that idea that you understand everything that we went through. So let's go to slide 3 of 4. What do you think would happen if I asked you to take this rectangle and dilate it by a scale factor of 2? I would expect the rectangle to grow by a factor of 2. If the scale factor is 1/2, I would expect the rectangle to shrink. Now, I'm not going to write by a factor of 1/2 because that's a little tricky to say that something shrunk by 1/2. So I'm just going to write that I would expect it to shrink. But let's draw what we would expect. So if it was multiplied by 2, if each coordinate were multiplied by 2, 1, 2 would go to 2, 4. Likewise, -1, 2 would go to -2, 4, -1, -2 to -2, -4, 1, -2 to 2, -4. So if we connect these points, we'll see that our hypothesis, our expectation was correct. We do get a larger rectangle. I know it's not exactly a rectangle because that's not 90 degrees, but it's the best I could do on this. So let's say we multiplied everything by 1/2. That means that 1, 2 becomes 1/2, 1. And yes, I know that fractions scare us, but it's okay. You don't have to be scared of them. They're here to help. -1, 2 becomes -1/2, 1. -1, -2 becomes -1/2, -1. And 1, -2 becomes 1/2, -1. Now if we connect all of these, I'll do my best to keep it straight, but no promises. Doesn't look like I failed on the first one anyway. But we have a smaller rectangle inside our original rectangle. So that's really all I wanted you guys to see from the Desmos lesson, having a little bit more of a hands-on experience with drawing them and looking at the scale factors. But now let's take a look at the model that I created for you guys in GeoGebra. We have sliders here to adjust the size of our rectangle. And we have a slider to adjust the scale factor by which we are dilating. So let's make this 1.5, so it's not crazy big, but you can see the rest of the shape. Now this worksheet goes along with the GeoGebra model, and we're going to be filling in this worksheet depending on the model, or according to the model. So the instructions tell us to roll a die. Well, I'm not expecting you guys to do that because then your answers will look different than mine. So let's just pick two numbers. Let's say A will be 3. Let's put this right. A will be A will be 3 and B will be 2. So with an A value of 3 and a B value of 2 for our sliders, let's say that our scale factor should be 3. So first we're going to adjust our A to 3 and our B to 2. So A to 3, B is already at 2. And we're going to record the coordinate points for A, B, C, and D. Well, A is 3, 2. So let's go back to our worksheet and write down 3, 2 for A. We can see that B is -3, 2. C is -3, -2. And D is 3, -2. And now we're going to adjust this with a scale factor of 3. So we can kind of start to build an idea of what we expect these points to look at, but let's change the scale slider to 3, zoom out a little bit, and let's read the coordinates of our new points. A prime becomes 9, 6. B prime becomes negative 9, 6. C prime becomes negative 9, negative 6. And D prime becomes 9, negative 6. If you notice, we just took all the x values and multiplied them by 3, and all of the y values and multiplied them by 3. So hopefully you see the relationship that x, y became 3x, 3y. Or we multiplied each coordinate by 3. Okay, so if you missed any of that, or if you're still copying down, that's fine. Just pause the video now to make sure you get it all down. Great. So let's look at, it says here card 2, but you guys don't have cards, so let's just make up some new values for your A, B, and scale factor. Let's call our A 2, our B 4, and our scale factor will be 1/2. So if I go back to my GeoGebra here, so my B will be 4, my A will be 2, and we're just going to copy down first the coordinates of the new shape, which are 2, 4, negative 2, 4, negative 2, negative 4, and 2, negative 4. So I'm going to go through that again. We had we have 2, 4, negative 2, 4, negative 2, negative 4, and 2, negative 4. And we want a scale factor of 1/2. So the first thing we're going to do is we're going to make a prediction. We're going to write down what we think the new coordinates will be, and we'll see if the model matches them. So 2 times 1/2 is 1, and 4 times 1/2 is 2, so that should be my new point. Negative 1, 2, negative 1, negative 2, and 1, negative 2. Should be my new vertices. And if you don't see where we got that from, we took a value like 2, 4 and made it 1/2 times 2, 1/2 times 4, which gives us 1, 2. So, if our scale is now 1/2, the new values are 1, 2, negative 1, 2, negative 1, negative 2, and 1, negative 2, which matches our worksheet exactly. So we can say that each x, y under the transformation is mapped to 1/2 x, 1/2 y, or each coordinate value was halved. So pause the video if you need to copy anything down, and if you have any questions, make sure to post them on Google Classroom or come see me during extra help either Tuesday or Thursday mornings or Wednesday during 5-2. Okay. So now we're going to actually perform a dilation on our own. We're going to take the plotted or the points that we were given to plot and plot them. So A at 2, 2, B at 1, 3, and C at negative 1, negative 3. And we're going to put them under a dilation by scale factor of 2. So let's connect these first, and we'll see that we get a triangle out of this. I'm going to do my best because I don't have a straight edge. And we get our first triangle. A was 2, 2, B was 1, 3, and C was -1, -3. And now we need to multiply them by 2. So that tells us that A prime should be 4, 4, because 2 times 2 is 4. B prime should be 2, 6, and C prime should be -2, -6. So let's plot those points. I'm going to change to this purple color for this, for these points. So 4, 4 should give me A prime. 2, 6 is B prime. And -2, -6 gives us C prime. So once again, I don't have a straight edge, but I'm going to do my best with these. That's not great. This one. And you can see that our triangle definitely did get larger. It'd be a little bit easier to see if we were graphed perfectly if I had a straight edge, but unfortunately I don't on my surface. Okay. That's the end of the video, ladies and gentlemen. Thank you so much for watching this, whether you were out and being responsible and looking it over, or you're looking it over because you needed something to study. Also responsible, and I'm very impressed. There's a homework on Quizzes that is posted to Google Classroom. I suggest that you do that if you are out, because it will be due tomorrow. If you are watching this closer to a test or a final, please ask me to open up that Quizzes if you would like a little bit of extra practice. It's only 4 questions. It's not too long, but it will give you some material to work with. I hope everybody found this helpful, and I will see everybody soon. Have a great day.